Good evening, everyone. I hope I'm audible and my slides are visible. Okay, so unfortunately, yesterday's session was only for half an hour because of a glitch from the Google Meet. So now I have changed the link to a Microsoft Teams link. And in today's session, we will be continuing from where we left in the previous session. So my slides are visible, right?
Yes, ma'am.
Okay, so in the last session, we were discussing revision of lecture 3, and we were looking at this problem that was given in the lecture session. So in the problem they have given a normal distribution and they have mentioned the mean and the standard deviation. The mean is 21 and standard deviation is 9. So that is the general notation of a normal distribution. And we are asked to find what is the probability that the weight is greater than 27 kg. So let's discuss the solution for this now. So now we already know the mean and the standard. We know the mean and the variance. So that is the notation of a normal distribution. I by mistake I told it's 9 is the standard deviation, but 9 is the variance. I am just correcting it here. So if the variance is 9, we know that to get the standard deviation from the variance, we have to do the square root. So that means square root of 9 is 3. So standard deviation is 3. And in the question, we are asked to find probability of weight greater than 27 kg. So this 27 kg can be written as 21 plus 6. And 6 is 2 into 3, which is 2 into the standard deviation. And now from a general normal distribution curve, it is a general like rule of principle that 95 percentage values will be lying within two standard deviations. So you can refer to the diagram here. So this is the two standard deviation mark. But they are asking what is the probability of values after the two standard deviations, that is after 2 sigma. So as you can see from this graph itself, after 2 sigma it is approximately this 2.1 percentage plus extra 0.1 percentage plus some other small values which is not shown in the graph here. So this value that you are getting here is an approximate value, but if you want to find the exact value, then we can use this normal distribution table that you can find in logbooks, or you can also use online calculators. So for example, if you go to an online calculator, then you can mention the mean and the standard deviation, and there is also an option to mention above what values or below what values you need the probability. So here I have mentioned about 27 like they have given in the question, and we are getting 0.0228. So here approximate value we got was 0.022. That small point 8 into 10 power minus 3 was missed in our calculations, that we can get if we calculate the exact value. So this was about lecture 3. Now moving on to the next lecture. So in this lecture, the concepts of mean and moments of x and variance was discussed. So the mean is also written as e of x, which means expectation of x. So here the power of x is 1, so it is just x power 1. But you can also find the expectation of x power m. So that is called as the mth moment of x, and variance is nothing but it is the second central moment, meaning that instead of m you have to substitute second, meaning you have to substitute 2. So to find the variance, it is the expectation of x minus expectation of x square. So expectation, I hope you all know that to find the expectation, basically we have to sum all the values and then divide it by the number of observations. So here in the variance formula, it is expectation of x minus expectation of x square. So first we have to find this expectation of x, and then we have to substitute into the bigger formula. And suppose you have something like a formula where you know one of the random variables x and the other random variable can be written as ax plus b, then you can just convert it as a into e power x plus b. And similarly for variance, if you know that the variance of x and if you have to find variance of ax plus b, then the formula will just be a square into variance of x. So these are some of the concepts that were discussed in lecture 4. So now this is a problem from the lecture slides where they have given the final volume, which is 100 microliter, and the average cell density, which is 1000 per ml, and they have also given the standard deviation of cell density as 10 per ml. And now we have to find the variance in cell numbers in the final tubes. So you can take a couple of minutes to go through this question and then we can discuss the solution. Can you see my slides or not? Yeah, I think now my slides are visible, right? Okay, okay. I'm just changing to presenting within Teams itself so that the video is recorded properly. Okay, so let's discuss the solution now. So here in the question, the first, these are the given that the final volume is given, which is 100 microliter or 100 by 1000, which is 0.1 ml. And the average cell density is 1000 per ml. And they have also given the standard deviation. And from the standard deviation, we can find the variance by squaring it. So 10 square is 100. And in the question, they had asked the variance in cell number. So cell number is nothing but volume into density. And now we can use this formula here. Variance of ax plus b is equal to a square into variance of x. So here d is the constant and v is the variable. So here instead of a we have to substitute v, and instead of x we have to substitute d. And so a square meaning it is v square or 0.1. So 0.1 into 0.1 multiplied by variance of d, it is 100. So the final answer is zero point 0.1 into zero point 0.1 into 100, which is 1. So now I have shared the slides in the presentation mode itself, like within Teams itself. So if you open the Teams window, can you check if you see it? Just make sure that the window is open. So I'm just resharing it because some of you have said in the chat that you're not able to see the slides. So I have reshared it now. Now can you check? So if I have reshared it now, and if anybody has any problem with seeing the slides, you can try to log out and log into the meeting again. Sometimes that will help. Okay, so let's go to the. So we have discussed the fourth lecture now. So in the fifth lecture, what was done was we discussed what is the variance. So to find the variance, you have to first find out the mean, and each value you have to subtract from the mean and divide by n minus 1. So if you are calculating from sample data. So that is variance. So variance is used to measure how much variable there is within one variable. But there is another measure called covariance, which is a measure of joint variability of two random variables. So the formula is covariance of x comma y. So here you have to, it's similar to the variance formula. So in the variance formula, you are subtracting xi minus x bar and squaring it. But in covariance, you have to subtract xi minus x bar and multiply by yi minus y bar, and finally divide by n minus 1. So this covariance will tell you how the two variables x and y are related. So for example, if they are independent, then the value will be 0. And so suppose they show an opposite trend, that if y is increasing with decreasing x, then the covariance will be negative. So now let's discuss the uh, problem from the lecture. So here you don't have to give the absolute value. They are just asking to guess the covariance of x comma y. So you can take it's a simple question. So you can take a minute to think about it, and then we can discuss it. Yes, so if you have the answer, you can just type in the chat box. Yes, Insha, the recording will be available. So it will be uploaded to YouTube and the link will be shared with you on the NPTEL portal. Yeah, so you're correct. The correct answer is about to, it's almost zero. Anyone wants to explain why? You can just unmute your mic and talk. Priyadashi, are you there?
Yeah, you are getting all sorts of value. You are getting low,
Hmm. Yes, yes.
getting high y,
Hmm.
low. You're getting high y, high x. You're getting a high x, low y. So there's no
Hmm.
there's feels like there is no trend between the data.
Yes, that's absolutely correct. So if you check, so it's a plot of x versus y. So even for the low values of x, you are getting both high values of y and low values of y. And for the high values of x also, you are getting high values of y and low values of y. So there is no clear trend in the data between x and y. So you can't um, say that they are related to each other or they are anti-correlated. So the values are all over the place. So the covariance is approximately zero. So if you draw a line here, then both you're getting high and low values. Similarly, here also you are getting high and low values. So the covariance is approximately zero. So this you can guess just by looking at the data. To find the actual value, we will need all the points which is not given in the question and they are just asking to guess. So this was about the fifth lecture. And the sixth lecture was based on the concept of Bayes' theorem and conditional probability. So for the conditional probability, this is the notation probability of x, there is a line and y. So this line stands for given. So conditional probability means probability of x given y. So for example, if you know that the event y is happening, then what is the probability that x will happen? So that is conditional probability. And the formula is probability of x given y is equal to the denominator is probability of x comma y, meaning that x and y, probability that both the events are happening divided by probability of y. And in conditional probability, the most important concept is the Bayes theorem. So in Bayes theorem, suppose you know this value, probability of x given y, then you can calculate probability of y given x. So the formula is probability of y given x is equal to probability of x given y into probability of y divided by probability of x. So these are the main concepts from the sixth lecture. Now let's discuss a question related to the sixth lecture. So you can take a few minutes to solve this and then we can discuss it.
Stop asking research questions to ChatGPT. Its answers are not reliable.
Okay, so I hope you had enough time to attempt this question. So now let's discuss the solution. So here they have given the sensitivity and the specificity, and we are asked to find the effect of the disease prior on positive predictive value. So with this we can solve using Bayes' theorem. So they are asking for positive predictive value. So positive predictive value means probability that the person is actually positive for the disease, given that the test is positive. So this, if you expand it with sorry yeah, this if you expand with Bayes' theorem, like if you apply the formula, probability of d plus given t plus is equal to probability of t plus given d plus into probability of d plus divided by, so in the denominator you have probability of true positives. But in the question we have not been given the probability of true positives, we have just been given sensitivity and specificity. So we have to um, break down this equation further so that we can use these numbers that are given in the formula. So this probability of t plus can be expanded to again we can use formula this formula to expand the probability of t plus. So this formula is the probability of getting a true positive is, so there are two cases. Either we get the true positive when the patient is positive for the disease, so this is the first term, or we get true positive even if the person is negative for the disease, so this is the second term. So probability of true positive given that the person is positive for the disease, this probability of t plus given d plus, this is nothing but the sensitivity. So this term will become sensitivity, and this term probability that the patient is getting a positive test although he is negative for the disease is specificity. So this term is, sorry, it is 1 minus specificity or the false positive rate, and the specificity value is also given in the question. And finally, probability of being disease negative is 1 minus probability of being disease positive, because probability of disease positive plus probability of disease negative has to be 1. So in this formula, which we have expanded to this, we can substitute all these terms. So finally we get probability, this PPV value or this prediction value. If you substitute these terms, so this term is sensitivity, so we have written it here, and this probability of disease positive, this is a variable. So this is a variable which is taking different values and it's given in the question. So this term we can keep as such, divided by this probability of t plus this term has become the sensitivity, and this term has become the 1 minus specificity. So what we have done is we have just modified this formula to fit in with whatever terms, this sensitivity and specificity terms that have been given in the question. So if you plug in the value, sensitivity is 99% or 0.99 and specificity is 0.98. So here you get 1 minus 0.98, and finally this 1 minus 0.98 is becoming 0.02. So now we have to plug in the different values of disease positive rate that is given in the question. And if we plug in the values, these are the values that we will get. So this is about the 6th lecture. Let's move on to the 7th lecture. So the 7th lecture was based on the concept of hypothesis testing. So hypothesis testing is used to test whether the trend that we see in a sample, whether it is common in a population or whether it is not common in a population. So the basic procedure is that first we assume a null hypothesis, which is the opposite of the experimental hypothesis. So for example, if you are measuring the tree height in a forest, then the population would be all the trees in the forest. But it will be practically difficult to go and measure the height of each and every tree. So typically what people do is they take a sample. So sample means a subset of the population. Instead of measuring all the trees, only some of the trees will be measured, and from that we will try to estimate the population. Yeah. So for example, in a forest of trees, your hypothesis is that the height of species A is lower than the population mean. Then that will be your experimental hypothesis. And the null hypothesis will be opposite of the experimental hypothesis. So in this case, the null hypothesis would be that the trees of species A are of the same height as the population. So that would be the null hypothesis here. So to compare this, we use the test statistic, which we will discuss. So again, it will be easier to discuss this with a problem. So let's go to the question here. So to find out whether this null hypothesis is statistically significant or not, we have to compute the test scores. So here in this example, there is a control sample and there is a treatment sample which has been treated with the inhibitor. And here they have given the t-value. So this t-value you can calculate from by doing a t-test. So, but in this case they have already given the t-value, so we don't have to do that. Now we have to find whether if we get this t-value, is the difference between these two groups significant or not. So you can use an online t-distribution calculator, or you can also use a log table. So I'm just so you can try it for yourself. I'll just copy paste the link so you can also try it. So I have pasted the link in the chat box. You can do it along with me. So you can go to the link here. And if you open the link, you will get a calculator of something like this. So to get the p-value from the t-distribution calculator, we have to know the degrees of freedom. So that is also given in the question. So the formula for degrees of freedom is n1 plus n2 minus 2. And here n1 is 5 and n2 is also 5. So degree of freedom will be 5 plus 5 minus 2. So in the degree of freedom box, you can write 8. And the t value is also given directly in the question. So the t value will be 3.855. And is the difference so there in the question you have also have to select whether it is one tail or two tail. So the difference is that one tail means you have to suppose you have to know whether the value is either greater or lesser, then you have to use one tail. But if you just want to know whether the value is different, it can be greater, it can be lesser, then you can use the two tails distribution. So here they are just asking generally whether they are different. They are not specifically asking whether there is an increase or decrease. So you can use the two tail distribution. And when you do this, the p value that you get is 0.004843. And so in the question they are asking is the difference different at the level of 0.01. So if you compare the p-value, it is less than 0.01. Therefore, it is statistically significant. So generally for these kind of hypothesis testing, we keep a cutoff p-value. And if the p-value is lower than that, then it is statistically significant. And here we are getting a lower value than 0.01. So yes, it is statistically, the difference is statistically significant. So this is the basic concept of how to do a hypothesis testing. So first you have to find the t value, and from that you can get the p value. Then the next step will be you have to compare the p value with the cutoff of the p value that we set. And if the p value is lesser, then it is statistically significant. So these are the, so now we have revised the lectures. And apart and the questions that were given for you in the lectures, so we can also discuss some additional problems so that you are more comfortable with these concepts. So this is the question: if two events A and B are independent, the probability of A is 0.3, probability of B is 0.6, and we have to find the probability of A and B. So this question is fairly simple. You can just use the multiplication rule because they have given that the events are independent. So probability of A and B, you just have to multiply the two. Probability of A into probability of B. Actually, my stylus is not working, so from the next lecture I'll use the stylus, then the writing will be visible. So it is 0.3 multiplied by 0.6. So the final answer will be 0.18, 0.18. I hope it's clear to all. So if anybody has any doubts, anytime you can raise your hand and ask a question. Now let's go to the next question. Which of the following probability distributions is a discrete probability distribution? So if you know the answer, you can type in the chat box. Yes, so most of you have got almost all of you have got the answer correctly. The correct answer is option C. So there are two kinds of random variables: continuous random variables and discrete random variables. So basically, similarly, there are also like continuous probability distribution and discrete probability distribution. And normal distribution is for a continuous variable, so it will look like a bell curve. And exponential distribution is like it will look like e power x graph, and that is also for a continuous variable. Binomial distribution is for a discrete variable. So in this case, binomial, like in the name itself, there is bi. So in binomial distribution, the main feature is that the random variable can only take two values. For example, in a coin toss, it can take head or tail. So because it is only taking two values, it is a discrete random variable, and this is a discrete probability distribution. So the correct answer is option C. I hope it's clear to all. Okay, great. So, again, if you have any doubts, you can just raise your hand and ask. We can clear it and then we can go to the next question. So, in this question, they have given x and y are two random variables such that y is equal to 3x plus 4 and expectation of x is 2. Calculate expectation of y. So, this also you can take a couple of minutes to solve it and then we can discuss the solution. So if you have the answer, you can write in the chat box, then we can discuss the solution. I hope you all, so whenever you come for the TA sessions, please have a paper and pen with you so that you can, when I'm discussing, you can also solve the problems by your own on the side. That will be more helpful than just listening to the lecture. So in this question they had given y is equal to 3x plus 4 and expectation of x was also given is equal to 2. So you can use the formula. So here probability of y will be, you just have to substitute the values, 3 into probability of x, which is 2, or expectation of x, plus this b value will be 4. So the final answer will be 10. So you just have to substitute the values into the formula. So I hope it's clear to all. So you have to add the constant term as well, 3 into 2 plus 4. So the final answer will be 6 plus 4, 10. It won't be 6. You have to add the constant term as well. So for the expectation formula, sorry, this will be expectation or probability. You have to add the constant. But for the variance formula, you don't have to add the constant. It will just be a square into variance of x. So don't get confused. So in the variance formula, the b term, the constant term will not be there. But in the expectation formula, the constant term will be there. So that's why it will be 6 plus 4. It won't be just 6. I think some of you have got confused. Okay, so I hope it's clear to all and we can move on to the next question. So this, once you have the answer, you can type in the chat box, then we can discuss it. கிளாஸ் இருக்கு So this is a fairly simple question. The question is, which of the following is a non-parametric hypothesis test? So there are two types of hypothesis testing, parametric and non-parametric. Yeah. And the main difference is that in parametric, the number of assumptions are more. Like you have to assume that the data follows a normal distribution and the variance is similar for all the variables, etc. But in non-parametric tests, we don't make such assumptions about the population distribution. So if you're not sure whether the data follows a normal distribution or not, then you can go for the non-parametric testing. But the advantage with parametric testing is that it is more powerful than non-parametric test, and there are different types of parametric test and different types of non-parametric test, and chi-square testing is an example of non-parametric hypothesis testing. So this is used when the data is categorical, and for if you want to test whether two variables are associated or not, then you can go for the chi-square test. So now let's move on to the next question. So once some of you have typed the answer in the chat box, then we can discuss the solution. So let's discuss the solution to this question now. So here they have given different limits of the integral and whether the values are greater than 1 or less than 1, etc. So they have given that the random variable x is ranging from m to n, and it has a probability distribution of f of x. So if you draw the PDF function, I'm just drawing something roughly. Then it will range from m to n. And maybe it is something like this. So so because they have mentioned that x is ranging from m to n, so I have kept the minimum value of x as m and maximum as n. And they have also given two more variables such that a and b, and a is less than b. So a will be somewhere here and b will be somewhere here. So because it is a probability distribution, the total area under this curve must be equal to 1. That is, if you take integration from the limit m to n f of x dx, so this value must be equal to 1. But in the option A, they have given this value is greater than 1, so option A is not correct. And option B, what they have given is integral m to a f of x dx equal to 1. So they are only taking the integration from m to a here, and they are saying it will be 1, but that is not true. So this total integration value will be 1. So this m to a value, this integral has to be less than 1. So option A is not correct. Option B is also not correct. And option C is integral between the limits a to b f of x dx less than 1. So this is correct because this entire integration is 1, but a to b is just a subset, so this limit will be less than 1. So option C is correct. And option D, they have given integral m to a f of x dx plus integral b to n f of x dx is equal to 1. So basically they have added these values m to a and b to n. But this value in the middle they have left out. So this value, actually it has to be less than 1. It should not be greater than 1. So option D is also not correct. So the correct answer is option C. I hope it's clear to all. Okay, so let's go to the next question. Yeah, so the first option is incorrect because the area must be equal to 1, but they have given greater than 1. And option B also, the range is smaller, so the probability has to be lesser. And option C is the correct answer, but again, option D, they have left out some part of the graph, so option D also is wrong. So this is the next question. You have to calculate the variance with the correction. So this also you can take a couple of minutes to solve, and you can type the answer in chat box, then we can discuss it. Okay, so some of you have got the answer. So let's check if it is correct or not. So they are asking to calculate the variance. So to get the variance, the first step is to calculate the mean. So you have to add all the values and divide by total number of values, which is 5. So the mean that you are getting is 15. And the next step is for each of the value you have to subtract from the mean and take its square. So calculate the squared deviations from the mean. So the first value will be 20 minus 15, and then 5 square 25. Second value is the same, 20. Third value is 10, so you get minus 5 square, which is 25. And the fourth value is just 15, so it will be 0. And the fifth value is also 10, so here also you get 25. And we have to sum these values and finally divide by n minus 1 because they have asked appropriate correction, so we have to use Welch correction with n minus 1, which is 4. So 100 by 4, 25. So the correct answer is 25. Okay, so most of you have got it right. So I'll just go back to the sixth question because I missed it by mistake. Yeah, so the sixth question is, which of the following is the correct PDF of exponential distribution? So option A, this formula is the PDF for binomial distribution, so this is not correct. And option B is the formula for Poisson distribution. So this is also not correct. And option C is for a normal distribution, so it's not correct. But exponential distribution means this e power term should be there, so it's a constant into e to the power minus lambda x, the constant, same constant both the places. So that is the PDF of exponential distribution. So the correct answer is option D. So this was a simple question, so I just discussed it directly. And this is also another simple question. What is the standard deviation of the standard normal distribution? Yeah, so the correct answer is 1, and most of you have got that. So they are asking the standard deviation of standard normal distribution. So standard normal distribution means it will have a mean value of 0 and standard deviation of 1. So that is the definition of standard normal distribution. Okay, so now let's go to the last question of today's session. So they have given data for x and y, and there are different options about variance and covariance, which you have to choose from. You can take a few minutes to solve it and type the answer in the chat box, then we can discuss it. கதவு மூடிடுங்க. Okay, so it's almost time to finish the TA session. So let's discuss this last question. So they are asking which of the following statements is wrong for the given data. So one approach to solve this question will be that we can, because they have given the exact values, we can substitute the values in the formula and get the numbers. But one more approach will be just by examining the data, we can try to guess which of these are correct, which of these are not correct. So the first option is about the covariance of x comma y. So here we can try to find if there is any trend between x and y. So here we can see that the values of x are increasing from 10 to 30 and the values of y are also increasing. So definitely the covariance has to be greater than 0. It can't be less than 0. So just based by this observation, we can say that option A is not correct. And option B, variance of x greater than 0. So again variance, when will the variance be 0? So if all the values are equal, only then the variance will be 0. But here we can see that different values, there are 5 different values of x. So variance of x has to be greater than 0. So this option is correct. And option C is expectation of y greater than 0. So expectation of y is the mean. So if you take a mean of it, it will come out, the value will be 10. So which is greater than 0. So this is also correct. And option D is expectation of y minus expectation of y the whole square. So this value is nothing but the variance of y. So this is the formula for variance, right? So this will be the variance of y. And again we can just have a look at the values, that the values are different. It is 0, 5, 10, 15, 20. So 5 different values. So the variance has to be greater than 0. So option D is also correct. So in the question they are asking which is wrong for the given data. So option A is wrong. So this will be the correct answer here. Any doubts or is it clear to all? If you have any doubts, you can raise your hand. Okay, so this brings us to the end of the TA session for today. So for those of you who missed the first class, every Sundays from 7 p.m. to 9 p.m. we will be having these TA sessions for problem solving. Actually, yesterday there was a technical glitch. That's why today is just a continuation from the yesterday's class. But Yeah, so this is the schedule for the TA sessions, and during these sessions we will be revising the lectures, and we will be solving the problems that are given at the end of each lecture, and after that we will solve some additional problems as well, so that it will help you to solve the assignment problems and get more clarity on the concepts. And yeah, so that is the main purpose of the session. And to make the most out of the session, I would suggest that whenever you sit for these sessions, you please have a pen and paper with you, because it will mostly be a problem solving session where we will be discussing question and answer. So it will be useful if you also solve the problems in the class itself by your own, instead of just watching me solve it. So that's pretty much about the problem solving sessions. So mostly the sessions will be on Sundays. If there are any changes, just keep checking your email. If there are any changes in the schedule, then you will get an email and you can attend the sessions accordingly. Any questions, anyone? So if there are no questions, we can finish the session for today. And yeah, one more thing, these slides and the recording of today's lecture will be uploaded. So if you have any internet connection problems, if you're not able to, even if you miss some parts of the class, it will be available online, so you don't have to worry about that. The slides will be shared, and the um, recording of the lecture will also be uploaded to YouTube, so you can refer to that as well. Okay, so I hope there are no more questions. I will end the session then. Thank you all for coming, and sorry about the technical problem. Hopefully, with Microsoft Teams, it should be fine. Okay, see you next class.